Thank you.
Thank you, Philipp.
Hi, everyone. Last session before lunch. Everybody still staying with me? Cool. Let's try to take this away and see what we can do about logging. Who feels good about their logging? Who thinks they need to do more about logging? OK, good. Then you've come to the right talk. Let's see. So oftentimes we start developing our application and you have something like Gradle run and everything is fine. And then you try to put it into testing and you cat on your logs and you see what is going on. And then later on you maybe do tail F on your logs and everything is still fine. And you always say this is fine and you know maybe this is not fine, but you kind of say like this is fine for now. And then you try to put it into production, and then suddenly you have 3 services running in parallel. And you need to see the logs between all 3 of them. And then you deploy it even further and scale it up, and then you might have more windows. And then you don't even know where you're connected to anymore. So you're all over the place, and you don't know what is where and how to get started. And then you basically say, this is no longer fine. And what we want to avoid basically is this bottom half where everything is on fire and terrible. So we want to avoid the we don't know what is going on in our logs. That's the general idea. OK, so we want to log all the things and see what is going on in them. One of the problems you might have at some point when you try to log all the things is that your log files get pretty large. Like you have something like this, where you have this largest log file, and then you have like the little submarine up there, that is you, and you're trying to grab something and find something in your logs. Who has the problem that they're trying to find something with grep and it's not working? Yes. Well, grep is nice and it works up to some point, but especially once you have a distributed system or your log files get very large, it's getting a bit more painful and you want to see a bit more what is happening in your logs. So why am I talking about that? I'm Philipp. I work for Elastic, the company behind Elasticsearch, Kibana, Beats, Logstash. We do a lot about search, but also logs and metrics and other use cases. But today we'll focus on logging. So a lot of you might know our logging stack ELK. Who has heard of ELK? Yes. Who is using ELK? OK. At least some. Maybe we have to work on that number, so let's see. So we have Elasticsearch, which is kind of the main component which stores the data. We have Logstash, which can parse and enrich the data to put it into Elasticsearch, and Kibana to visualize it. What do I mean when I say parse? Why do I need to parse? What is the parsing part? So the parsing part is generally we have a log line, and we might have like a log level or a timestamp. And you might want to extract those so that you can efficiently search on those or just group and filter on them. So that's what you do for parsing the logs. What could I mean when I say enrichment? Why would you want to enrich your logs? What is the enrichment part? Enrichment could be something like adding metadata. For example, you have Docker or Kubernetes logs. You might want to have the Docker or Kubernetes metadata, so you know from which container is this coming from, or what is the namespace this is running in. So it's not just the raw logs, but also the meta information. Or you might have an IP address of a user, and you want to say, like, I want to know the geolocation of the user. So I need to do a geo lookup on that IP address. All of that would be enrichment, what we add to the logs. And then, this is all nice, but then we added Beats, which is like a lightweight agent or shipper at some point, which is written in Go, so you have native binaries, and you can easily ship forward logs and events. The problem is there is no B in ELK. And, well, we have the ELK, and now we have a B. What could you make out of ELK and B? Our solution was this. You see, it's an ELK and it's a B, and we call it the BELK or the ELK B. It's kind of the combination of both. But is this really scalable? What happens if we have another product? Then we have another letter, and it will be very hard to make up another animal. So that's why we kind of like the ELK or BELK, ELK B is nice, but it's not really the final solution because it will not scale marketing-wise. And we always think about scaling. So what we have done now, we just called it the Elastic Stack, and that's kind of very scalable because whatever products we have, we just put them in. You might have to add some more colored squares in there, but otherwise it's always the same name. It's a bit like You still get the emails from recruiters who ask for J2EE developers. And that has been like 10 years ago. We don't want to be in the same situation that people always use an old brand name. That's why we try to find a brand name that will stick for us for a long time. That's the general idea. Okay, so the general idea is you have beats, which are like the lightweight shippers. They can forward to Logstash for the parsing or enrichment, or beats could also talk to Elasticsearch directly, and then Kibana can visualize everything that is going on. And that's pretty much the stack that we're using. But the patterns that I'm showing you today are generally applicable. So if you have any other centralized logging system, you will find very similar things. And if you don't have any centralized logging system yet, you will at least get an idea of what might be the pain points or what is the approach that you might want to take in the future. So most of the things are very general, what I'm showing you today. So I built Hello World applications, and today is no exception. Like, this is the Hello World of logging we're using. So it will not be fancy or super complex, but it will show you the right patterns of what you can do around logging in those. And before I dive into that, or let's talk quickly about the technologies. So we're doing Java, and I'm using SLF4j as my logging facade and LogBack as the backend. You could also use Log4j. It doesn't really matter, like, there are alternatives, but my stack today will be LogBack and SLF4j. That's how we log. What was MDC again? Who remembers what was MDC? Shout. What was MDC, or what does it stand for? Yeah, so MDC stands for Mapped Diagnostic Context, and it's basically structured information you want to add to your logs. For example, if you have users that log into your system, you might want to add that username to the log event. So if somebody complains afterwards and says, like, your page is full of errors, you might just pull up the logs of that specific user and look what did they do or what happened to them. Or you might have some other tag that you want to add to an event. This just makes it easier to have structured information with your logs afterwards to filter down and see what is really happening in one specific use case or to one specific business unit or user or whatever makes sense for you. You could do what I'm showing you today in any other programming language. You shouldn't bash PHP too much because even they have a proper log appender nowadays. So even there, you don't have any excuse not to do proper logging. And the two things we don't want to do is, the first thing is, we don't use print for logging, right? I hope everybody agrees. Otherwise, we can have a discussion afterwards. Because we want to have proper logging levels, and we might want to turn them up or down, so we don't just print. If you're using print, yeah, we can talk about that afterwards. You don't have to tell everybody here now, but we can discuss afterwards. The second pattern we want to avoid is too much coupling. So coupling could be either configuration-wise, like your application ideally doesn't even know about the logging backend, because when you change something in your logging backend, you would have to redeploy or change your application, and there is really no point to that. You don't want to have this coupling. And the even worse coupling would be like at runtime. If your logging system is down and impacts your production application, you have a very bad dependency that you really don't want to have. Like, it's bad if you don't get logs, but at least if the logging system is down, it shouldn't kill your production application. So we don't want to have dependencies like those. So, and with that, we can dive in. And before I dive into the pattern, first let me start my demo. Let's hope the demo gods are with us. So this is all containerized, and if you want to run it at the end, it's just basically Docker Compose up. It will download half the internet, but then you can run my entire demo yourself. Hopefully everything works. While this starts up, I will quickly show you what we are doing in our Java application. Is this large enough for everybody to read? I hope so. So I hope we're good. So we're having a loop, and we're looping from 1 to 20 just to get some log events. And for every time we run through the loop, we add some structured information. The structured information we use here is we use the count in the loop, and I also have a session. But the session is just a random number. This is like your user. I don't have proper users in my system, but let's assume the session would be like proper usernames, and we could filter down on just session 15, and that would be a specific user. So this is kind of the scenario where you want to have that. So for every loop iteration, I add a trace statement. with that. And then we have this pattern here. So if the number is can be divided by 15, I have a runtime exception. If it can be divided by 5, a warn, by 3, info, and otherwise a debug message. What is that pattern that we have down here? Who has been doing job interviews lately? Anybody knows FizzBuzz? Where depending on where you are, it will say fizz or buzz, depending on how you can divide the number. And I've basically written FizzBuzz for logging. It's not very meaningful, but it's just a demo to get some logs out of this. And we run this in this loop. How many logging events should we get out of this? Take a moment to think how many you think you will get out of that. Who thinks it should be 19? Who is for 20? Who is for 38? Who is for 40? Everybody should be raising their hand now. So it should be 40 because we have a loop. We're going from 1 to 20 inclusive, so it's 20 loops. And then we have one trace statement and one of these down here. So we expect 40 events. Remember that number because the 40 events will come back to us later on. So this is generally the application that runs. And I have containerized all of this. So this is the Java application container that we have running here. I add some labels. We'll get to those later on. And this is basically just putting the logs from the container on my host. And then basically I have FileBeat as a sidecar, and that will collect those logs and forward them. So what we have in our pattern here, this is the general setup. So we have the classic log file. We write out the log file. Then we have FileBeat that tails the file, basically. I always say FileBeat is a bit like tail F, but over the network and on steroids. So it's just tailing the log file and forwarding whatever ends up in the log file. Then we put it to Logstash to do the parsing, and then we store it in Elasticsearch and visualize it with Kibana. And that's all there is. So how do we get the logs out of the Java container and to FileBeat? Well, we could put FileBeat into the Java container, but that's not very elegant. Like, we have another dependency, it's just a larger container, you have a coupling, you don't want to do that. So what I do is, from the Java application, I put my logs on the host. So from within the Java application, where it logs to logs, I put it on logs Docker, and then in the FileBeat sidecar, I take those logs and put it inside the container. And then my Docker FileBeat can just take those logs and forward them. And then, just to collect the log files, I basically say, like, okay, anything that is a log file, I want to take and forward. So that is what we're doing here. And we can add some metadata as well. So while I have been talking, hopefully my application has come up here. We'll see in a moment. Let's say this is the right window. And now it's the question if the demo gods are with us, but it looks good so far. So let's have a quick look. This was the Parse example. So we have an index called Parse here, and it has 42 events. I mean, 42 is generally always the right number, right? But is it the right number for our example today? No, because we said we expect 40 events, right? Now, why do we have 42 events? Does anybody have a guess already why we might have too many log events? No, it's not the startup. It's just the raw logs from the application. There is nothing from the startup. Let's have a look at the actual logs. So when I had over here, I see the events. I see this is when we started everything, and we have 42 events. And I can open one up. And you can see these are all the attributes we have collected. So for example, we can see this is a debug message. It was the random session 6 and the 19th iteration in the loop. You can see this was the actual log message. And we have collected that. So let's take a look at the log level, for example. I'll just toggle this column so we can see all the columns. And you can see most of them have a log level, but 2 don't have a log level. Let's open one up. What is this one? So you can see here, what is this? It's one line of the stack trace, because we had in our application, here, we have this one here, the runtime exception. And this has a stack trace with 2 lines. And those are our 2 extra events that we have. So the ones we have here, this one here, and this one here, you can see this is the runtime exception. Is one line of a stack trace very helpful on its own? Not really. Like, one line of a stack trace doesn't help you at all. So you should not break this up. It only makes sense if it's combined. Do you think it's easier to not break up stack traces in the first place, or putting them back together afterwards? Who thinks it's easier not to break them up in the first place? Who thinks it's easier to combine them again? Okay, nobody thinks it's easier to combine them. That's good, because that's pretty much like hashing meat. Like, if you have the meat grinder and you put meat through the meat grinder and you have the hashed meat afterwards, putting it back together is almost impossible. And you have the same with the stack traces. Like, putting back the individual lines of a stack trace is very hard work. You don't want to do that. So what you want to do is basically, when you run your Java application, and we can just quickly do that, when I just run that, you will get some log events. So this is what we get. Any guesses how we could make sure we don't break up this part here? So what we have basically is, when you look at it, you see that every log line that we have starts with a square bracket. But these ones, which are part of the stack trace, they don't. So basically what we do is, when we collect the log file, we want to say, like, every new line starts with a square bracket. If it doesn't start with a square bracket, it's the continuation of the previous line, and then it shouldn't be broken up into another message. That's the general idea. Where do I configure that? In the file beat that is collecting the log file. And so we need to fix that. So we have file beat for log stash, and here I have already commented that out, because this is the setting that we need. So what we have is, we need to say, like, when you collect this, this is a multi-line statement. And if it starts with a square bracket, then it's a continuation of the previous line, and it should not be broken up. And this will reload automatically in the background, so I can just restart the Java application to generate another round of logs, and these should not be broken up this time. So let's see which Docker containers we have here. Somewhere there is a Java application. If I would just see my Java application. Where is Java? Here it is, my Java application, and this is the ID of the Java application. So we need Docker restart, and we'll just restart that container. And it will generate the logs again. So, in my parse index, where we had the 42 log lines, how many log lines or log events should we have now that I ran this again? Well, we have 42 from the first one, and then we try to ideally add 40 in the second one, so ideally it should be 82, hopefully. Yes, question? No, because we should not break up the exception. That's exactly the point. It should be only 40. It should be exactly 40 this time. And, well, let's see if I head over to the overview of the index. We can see parse has now 82 log lines. So this is luckily exactly the number we expected. So we have 82 events, and this all worked out. And if you look at them now, you can see now, first we had 42, and now we had 40 events, so all is good. We don't break it up anymore. And you can see, for example, if I look into error, you can see this here contains my log message, and this is just all one, and it's not broken up anymore. So this is good. By the way, you can see we support emojis everywhere. So if you look at it in less, for example, I think the emoji is not showing properly, but our stack nowadays supports emojis everywhere. So you can always add like a user experience to your logs and filter down on that to see how people are doing. Because obviously emojis are the #1 thing for logs that you need to have. Okay, so looking at our original log message here, you can see this is just one log line. And looking at the log event, you can see, for example, we have the log level. So we have broken out error. How do I extract that error message from my log line? What do I do? Well, I run a regular expression to parse it. Who likes writing regular expressions? Yeah, that's not so many. And those who raised their hand, I would say that's probably the Stockholm syndrome, where you got so used to writing regular expressions that at some point you start liking it and you accept it. I don't like writing regular expressions, but we still have to do it because we want to parse this now. So let's take one log line here. And the easiest way to write that regular expression is we have something called a grok debugger here. And the thing that makes this nice is you can just add a sample log line, this one here, and now I can start writing my regular expression to parse this up the right way. Now, those who said they like writing regular expressions, now it's your turn to help me out writing the regular expression. Because obviously you like that so much. So, how do we get started to parse this one here? So it's the start of a line, so we will start with that little roof icon. And then we have a square bracket. So we need to escape the square bracket. And then we have this timestamp here. But this is not just plain regular expression, this is grok. Grok is basically named regular expressions. So the nice thing about grok is, and let me open up the right part of the documentation here, it's basically, if I was connected to the internet, let me quickly fix that. What you get is, you will basically have prepared regular expressions that you can just reuse for known things. So if I make that slightly larger, you have, this is basically the name you can use, and this is the regular expression behind it. So you don't have to write the raw regular expression, but you can reuse those parts. And we have a full section of timestamps here, and the one we need is this one here, because this will parse our date correctly. So what we do now is we say, you need to say %, curly brace open, the pattern you're using, so this is the pattern I'm using, colon, the field into which I want to put this, so I call this add timestamp, and then I close this. So when I run that, it will show me, okay, it has correctly extracted that. What do we do next? We need to close the square bracket. Then we have a space. You could either just type space, or another nice trick is you can use this one here. This one is nice because it eats any white space. So any one or more spaces or tabs, all of them are eaten up, so you don't have to care if it's one or more spaces. So you can just use space here, and then we could say like this might be called, I think it's called word, and we put that into a field we call log.level. And then we try this again, and you can see now we have extracted the log level as well. Do you want me to write the entire regular expression for this line? Probably not. So like in every good cooking show, I have prepared the regular expression for us already. So it is in my log-configuration file, which is this one here. And this is the regular expression I want to have. So I can just reuse that one and run it. And then you can see now this is breaking this up. So this is the regular expression that parses our log statement correctly, and this is what you get out of that. And this is what Logstash is doing in the background. We've seen the dev tools to actually debug that. There is one other way. For those who don't like writing regular expressions, there is another tool to make your life easier. It's called AutoCrock. It's part of our, we call it machine learning. I'm not sure machine learning is really the right term for that. But what it does basically is you can upload a file. So we'll just upload my Java logging, log stocker. I will just upload my log file, and it will be analyzed automatically, and then it will try to generate the right grok pattern for me. So what you get here is, you can see this is the log file that we have. It says like, I have found 83 log events, and this is the regular expression it is suggesting to use for parsing. This is not perfect, but this is a good starting point. So this can speed up your regular expression writing or grok pattern writing quite a bit. And it also shows you what it has extracted. So it saw, like it found these log levels automatically. You see that the loop count, so 1 to 20 it would be, the message, the session, and the timestamp. So it could extract all of those correctly. This will make your life much easier if you have a lot of log files and you need to parse them. And we can even break up like key value pairs, but that's a bit too much for today. So the good thing about this approach is you don't have to change anything. You have your classical log file, you write it out, and then you run regular expressions to parse them if you like to write them. Be careful not to break up multi-line statements. And there is a bit of coupling because every time you change the log format in your Java application, you also need to change your grok pattern to reflect that change. So you have a bit of coupling, but it's not really a runtime, it's just a setup or configuration change. So what might be an alternative approach to getting logs? Because it's kind of stupid. We have our application has the log structured, writes it out to a file, and then we parse it back to extract all those fields back. How could we do that more intelligently? Yes, JSON is the third step. We'll have one more in between, but JSON is actually a very good approach, but we'll do one more in between. So what we have is we could send it directly to Logstash, for example. So what we have is we have the right log appender, we send that to Logstash, and then we just store that. And that's already structured, so you don't have to do any parsing. And for example, if you use Logback, this is all you need to do, because your application already knows how the data is structured, so it just forwards the right information. So you can see here, you have a Logstash access TCP socket appender. This could also be UDP if you prefer that. This is where Logstash is running, so your application needs to know where Logstash is running, but okay. And this is all you need to configure in Logback to actually do that. And then you're done. So, I don't want to do that now. What is the downside of this approach? Anybody can guess the downside? Let's look at our log events. So, this was the parse index where we had the 82 events and this was good. We have sent, this is the current example, and this one has 40 events. What happened here? Why do I only have 40 events? Well, when my application came up, Logstash was not available yet. So my application ran, couldn't reach Logstash, and just threw away its logs, because Logstash was not there yet. Generally, Logback, once it has reached the log appender, it will buffer up to 200 megabytes of logs, but afterwards you would lose log events again. So if your logging system is down, you might lose log events, as we have done when we started up the application. And that is kind of the main downside already. You have a bit more coupling because you have this direct connection to your log event system, and if it's not available or you have too many logs, you might lose log events. And maybe you don't want to have that. So, you don't have files, so that's good. You don't need to do any parsing. Multi-line statements are also not a problem. Everything works, but you have a bit more coupling, and if your logging system is down, you might lose events. And normally, whenever your network is not working correctly, then it's when you're most interested in the log events. And then it's exactly when you don't see it in the logging system because the network is not getting you the messages through. So it's kind of a stupid problem to have. Exactly then when you're most interested in the logs, you don't get them, which is not the great place to be in, so I would be careful. So somebody mentioned JSON already. JSON is kind of the perfect format for us because Elasticsearch is also storing JSON. So basically what you do is when you do that is you write out a JSON file, FileBeat is tailing the JSON file and puts that into Elasticsearch directly, and you're done. And that's all you need. So what that looks like is, first let's look at Logback. So we have, this was the Logstash appender, this is now the JSON appender. This is also a rolling file appender, so it will roll over files at some point. And you can, for example, say here, this is how we want to structure the JSON event. So you can say log.level is the level, and so you can just structure the message. And this will spit out the JSON log file. So if I look here, .json, you can see session, loop, everything is structured and working well. How does this handle our stack trace? Will the stack trace be one line or multiple lines? It's only one line. So what we have is we can just scroll to the right, and the longest message is the stack trace. Here you can see wake me up at night. That's a runtime exception, and you can see \n, and then there was a tab. So this is the new line, this is the tab. This is how we delimit that. So it will be a single line, and your entire stack trace is a single line. but Kibana will still be able to interpret that correctly. So this is also working as expected. And when I look here, you can see this was the structure approach. This had exactly 80 messages. So we didn't have broken up lines, we didn't lose any log messages, and we didn't have to do any parsing. So this is a very nice combination of all the features together. And when you look at those, let's head over to the parse one, to the structure one. And I've been talking too long, so we might have to go back 30 minutes in time. And you can see here we collected 40 events, and here we collected 40 events. And for example, if I find my error message, this one here, you can see it has the user experience, it has the log message, it has all the parts, it even has the error.message. So this is our stack trace, and this could be very long, but it has all the right pieces, and everything is there and in place. By the way, I also enrich my logs with the host information, so you could see on what platform this is running. So you know which operating system. We could enrich that with your cloud provider's information. So if you're running on AWS, we would know the region and the instance ID. If you're running on Docker, we would get the Docker metadata. For Kubernetes, the same. So we can enrich those events with some relevant metadata to make it easier to work with your logs as well. Okay. So we've collected. That is the only thing that you need to change in FileBeat. Basically, you need to tell FileBeat, well, this is a JSON file. So parse it or process it correctly, but you don't need to write any regular expressions or anything, and then it will just be stored correctly and you're done. One other nice feature is that you have a stack trace hash, and this one here is in the error message, the stack hash. This one here, this hash is a hash of this part here. Why would I might want to have this hash? Yes, it's very easy then to say like, how many different stack traces do I have in my system? And then you could say like, which one appears most often? You can just aggregate on that key. So that stack hash is very easy to see like, how many unique errors do you have? How are they distributed over time? And maybe how many users are affected or something like that with the metadata, you can use that. Who is calculating that stack hash? The log appender. This is a feature of Logback. So my log appender is calculating the hash and just stores it in Elasticsearch. This is nothing we do in our stack. This is just part of the log appender that we're using here. Okay, so it's the right format. We just need some JSON serialization overhead, but mostly you can live with that. Okay, if you want to containerize your application, and I assume most of you are using Docker, where do you put the beat? Generally in a sidecar. So it's, you have all your containers running on your host, and then you have one other FileBeat container that can collect those files. Where do you ideally get the logs from in that sidecar? Ideally, your Java applications write out to system out, and then it will land in the default Docker log, and then we can just tail that. And then we don't need to set up like folders and files, how to map stuff around. So basically what we do is, so this is the general idea. Your application writes to the default Docker log, the FileBeat will tail that and just forward that. So what that looks like in code is, your Java application, the log appender that we're using in this example is the console one, because we're just writing out the log events to system out. And then we have, in the Docker Compose file, what we do is we have FileBeat Docker for Elasticsearch, that's the right one. We basically mount, this is the default location where the logs end up. We mount that into that sidecar, and it can then forward all those logs. And just to give you an idea of what that configuration looks like, FileBeat Docker, all we have to do here is basically we enable this setting. So we say FileBeat auto-discover, and this is Docker. And the FileBeat knows the right location, where are the default Docker logs, and it just collects them and forwards them. You don't need to set up any paths or anything. It knows automatically what to do and do the right thing here. So, if you want to have the examples, I have them in my demo, but we also have them in our repository on GitHub, so you can just copy them from there as well. It's a bit hidden, but it's in deploy Docker. There we have the recipes for all the beats. By the way, if you want to take pictures, I will have one link to the slides and the demo at the very end. That's probably the one link you want to have, and from there you can find everything else as well. So this is how we collect the Docker logs. That's working. And one other nice thing is we can add the Docker metadata to this. So when we collect the logs, what we get is this. For example, you can see here, this is the hash of the container. And you see these are the labels that we have on our container. So all of this metadata is then added to your log events. And you can see how that is going. Sometimes you might miss the very last line, because Docker log doesn't always add a new line to the end. And FileBeat always waits for a new line to collect the log line, because otherwise it's not sure if the line is complete already. So sometimes you only get 39 events out of that. But most of the time you get 40 actually. Another nice thing is, rather than configuring how to parse which file, we can do a bit of an inversion of control. So what I do here is, on the container I set some labels, and FileBeat will pick up those labels when it kind of looks into that container and says like, oh, these are the right rules to get the logs for this container. So here, this is the same multi-line pattern that we've seen earlier, and I just bake that into the container image, and the FileBeat would apply these rules then as soon as it tries to collect logs from that container. So this is kind of like, it's in one place where you configure how this should be set up, and that's because the container will know how its logs are structured. So you have less of any like configuration problems around that. Another thing that is important is we have a registry file that keeps track of how far we have come in a log file. So it basically is an offset and knows I have sent all the logs up until this point. And I don't want to keep this in the container. I want to mount this out to the host. Why might that be interesting? Because if I replace the FileBeat and roll out the new version, for example, and it doesn't know what has been collected from the log files already, it would just start from the very beginning of the log file, and then you might have duplicate log events. By keeping that registry file outside, it will know what has already been collected, and you will not have duplicate log events when you replace the FileBeat. So that's another important trick to avoid duplicates. You could say, for example, like if my container name has Java application, then I would want to put that into a specific index, so you could customize that if you want to. So let's look what data we have here. So if I look at that, and Docker is the one we look at, why do I have so many log events in Docker now? So the thing is here, this is not just a Java application, but these are all the containers that I have running. So these are logs from Elasticsearch and Logstash and FileBeat, like all the logs that I have are combined here. So what we want to do is we want to filter down on those. And we could do that in Discover, but we also have another visualization that is kind of nice. This is a bit more like tail F. And just to give you an idea, we need to set up where we can find or which index we want to work on. So I am interested in the Docker logs. So I update that and I close that. And here you have, these are all the logs that you have. But the nice thing is you can just filter down on the container that you want. For example, I know that I have container image name equals, and then it will suggest these are all the containers that I have in my system. And I'm just interested in my Java application for now, so I will just filter down on that Java application. And I don't want to combine this with anything else for now, I just want to see this. So you can see these are just the log events here. And if I run my Java application again and switch back, you can even turn on live streaming. This might have a delay of 1 or 2 seconds, but then this will just be like tail F. So this will show you live all the log events that you get in your system. So in any moment now, the 1041 should jump to 1102. Okay, now you can see it. Now we've collected the last log lines. So you basically can just tail the application, and this is like tail F, but with the advantage that you can also filter down on stuff here and have all the metadata around from Docker. So this makes working with large log files very nice. We can skip that for now. That's probably too much. Some applications want to be funny and have this ASCII art when they start up, like Redis, for example. Is that very helpful when you want to centralize your logs? Probably not, because this is just garbage for a centralized log. What you can do is, you can basically say, like, based on the Docker metadata, if some image is based on Redis, I want to exclude specific lines, and this is the regular expression to exclude the ASCII art. So this way you could filter out the ASCII art of Redis and get rid of that, or anything else that you think is just garbage and noise in your logs. One other important thing is who logs the logger. So if the file beat has an error and it puts the logs into the Docker default log, and then it tries to collect the same log file, you will have a logging loop. So what you do is, for that one here, I'm not logging to the default Docker log, but I will log to a specific file. And then, to avoid that logging loop, I log to that different file to not have a logging loop and be running around in circles. Okay, so it's hot stuff, but it's a bit more complex than without Docker, which, yeah, you have to live with that. And very quickly, anybody using Kubernetes? Okay, that's not that many. We do tie into Kubernetes, so if you want to do that, it's just the same. There you have just a daemon set, so it runs once per host. We have the samples again in our GitHub repository, so you just see the recipes. Basically, what you can do is to get the Docker metadata, you can just say like, FileBeat is running as part of the Kubernetes cluster. This is where the API is, and that's how you get the metadata. And then you would have something where you see this is the right namespace, this is the node where this is running on, this is the pod, so you get all the metadata from Kubernetes. And you don't have to do anything else. We have more metadata, but that doesn't matter for this example so much. This is how you would remove the ASCII art from Docker, or sorry, from Kubernetes. And you see here we're just using the namespace Redis. So anything running in a Redis namespace, there we will apply this regular expression. You could also customize your index pattern. So for example, here you see if we have a Kubernetes namespace, we use that index name. Otherwise, we will use FileBeat, and then we have the FileBeat version and the date, for example. So you could have one log or index, log index per Kubernetes namespace as well. Even hotter, but even more complex. You have to live with that. So to wrap up, if you want to try that out, if you want to take one picture, this is the one, because this also links to the slides again. But I will tweet out the slides as well. This has all the samples. You just do a Docker Compose up. It will download all the images and just set up the demo exactly of what I've shown you today. So you can just try that out yourself. So this is the one you want. Otherwise, we have looked at these samples. I don't think there is much point in repeating them because you've seen them. Before we do questions, I normally try to take a picture with you so that I can prove to my colleagues that I've been working, because they normally don't know where I am. So everybody wave. Thank you. Questions. I think we have like 4 minutes for questions, unless you run off for lunch immediately. Any questions? I think we have 2 over there. One moment, the microphone will come.
Thanks for presentation. I have actually a couple of questions. If you can tell very quickly, MDC versus Zipkin, what would you prefer?
Sorry, MDC versus?
Zipkin. It's a login library. Maybe if you...
No, I don't know.
It's actually... okay. The other is, like, if you have an application which is writing like 10-15 gigabytes per day, and it's actually in the cloud, it means like if you have a spike someday, it can be 60 gigabytes per day. Do you find this ELK a good solution?
Okay, I have a very hard time understanding you, unfortunately. So if my logs jump from 15 gigabytes to 16 gigabytes, then...
To 60, yeah, like triple or...
Yes. So generally, what we would recommend, that's a newer approach, is that you have like, we have a setting called rollover, where you can basically say an index should have this size, and once it had reached this size, it will roll over to another one. So it's not like a daily index pattern, but a rollover. So it will change automatically depending on the size, and then you don't care about it anymore. Then you just care like, okay, I have collected this much data in one index, and as soon as it's reached, I will go to the next index, and then I will go to the next index. The way to set this up correctly is called Index Lifecycle Management, ILM, which is part of the more recent versions of Elasticsearch, and that will basically take care of that. So that can roll over the data when you need it, and it can also remove old data when you don't need it anymore. So you can basically say, I want to keep my data up until 3 days or whatever, and it will remove all data automatically. And it will do that rollover to keep your indices in kind of like a similar size to avoid problems like that. That's the right approach for that.
Okay, thanks.
And if you have any other questions, just find me afterwards. And also, we have a couple of stickers here. If you want stickers, grab stickers here. That's your chance afterwards. One more. Final question.
Thanks for the presentation. Actually, my question is not a lot different from the previous. One thing we want is logs available for analysis forever. For example, for years, for decades. We have business need to analyze user actions for years. What strategy do you propose to have in order to not require much larger file system resources than your actual log, for indexes, than your actual logs?
So, I hope I understood you correctly. The question was, what strategy do we have to not write too much to files and then centralize it?
To keep the index size in check when you have the need to keep your logs for all your logs or some of your logs for a very large period of time.
I mean here, for the application servers to keep the logging size down, I'm using the rolling file appender, and this is kind of stupid because this is just going for 7 days. But you could also define that by size. So you just say like, after 100 megabytes, create a new file and then keep 7 files around. So this is on the server itself, it's kind of limited how many logs you keep. And then for Elasticsearch, for example, there is this index lifecycle management tool where you can also define, this is the retention time I want to have, and after that, just remove all the data. So this could all be automated. You don't have to manually delete anything. So how that looks like, basically, since everybody who wants to go for lunch can go for lunch, just to give you an idea, you have this policy here. You can see the FileBeat policy that we have here says like, this creates 50 gigabytes of data, and then it will roll over to another phase, and at the end you could say like, I have a delete phase, and I can say like, after 3 days, I want to remove this data. So this would clean up automatically, or whatever retention period you want to have. So this is how you could automate all of that. Cool. Thanks for having me. Grab stickers, enjoy lunch. Thank you.